Hi Math 8, this is 6.3, solving equations involving fractions. If I were to ask you, what could you multiply, what thing could you multiply by 3 over 7, this fraction here, to make it equal to 3? Try it out. Well, if you think about it, 3 over 7 is kind of like 3 divided by 7. So to get rid of the divide by 7, you'd have to multiply by 7, right? 7 times 3 over 7 equals 3. If you try that out, try it out. Take 7 times 3, then divide by 7, you'd end up at 3. What about this here then? What about, what could you multiply by 5 over 6 to make it equal 5? Well, if the number was the denominator here, then you'd assume it'd be 6, right? So 6 times 5 is 30, divided by 6 is 5. Yeah, so it would have to be 6 times 5 over 6 equals 5. You can have brackets or not, doesn't matter too much. So, think about it this way. What about if I want x over 7 to equal to x? What would I need to do that? What would you need to multiply by it to get x over 7 to equal x? Well, again, doesn't matter if these are variables, it would have to be that denominator. It would have to be 7 times x over 7 equals x. So, if you get in an algebraic equation some variable over a number, and what you're trying to do is make it into x, just figure out what the variable is, all you need to do when it's over a number is to multiply by that same number. So let's look at that, because that's the majority of what our assignment is today. And if I'm going to write this in here, I mentioned it last lesson at the end, but the opposite of addition is subtraction, and the opposite of multiplication is division. And I've said this in many videos. The division sign is the division sign. Why? Because these numbers, so for example, 6 divided by 3, that dot on top represents the number that's before, and the dot on the bottom represents that one. So this means the same thing as 6 over 3, which is 2. So remember, these are opposites, and these are opposites. So those are what we will use to get rid of things that are with our variable. So when you have x divided by 7, to get rid of it, we're going to multiply by 7. So let's look at some examples here. X over 4 equals 8. What could we get here? What could we multiply here in order to make this x be by itself? Well, it's just going to be what's on the bottom. Because this is divided by 4, we're going to multiply by 4. And so that means we need to do it to the other side as well. So what we're left with here is x, and then 8 times 4 is 32. Verify. What is 32 over 4? Does it equal 8? 32 divided by 4, it is 8. And so it's verified. That's a pretty simple example there. But let's do a couple others. A little more difficult. Let's throw in some negatives. What if we have d over negative 5 equals 15? Well, what we need to do is multiply both sides by what's on the bottom here. Is it 5? No, it's negative 5. So we're going to multiply this whole fraction by negative 5. We're going to multiply by negative 5. So this becomes d, and 15 times negative 5 is 75, but it's negative. Why? Because positive times negative is negative. So d is negative 75. We can verify negative 75 instead of D over negative 5 equals 15. Negative divided by negative is positive, and 5 15s makes 75, so it is indeed 15 equals 15, so it's verified. I'm going to show you a more proper way to draw in this multiplication here, and it involves me needing to leave a little bit of extra space. So I'm going to do this one more time here. Let's find a good question. I'm going to take C over 40 equals 10, what was it going to do? 120. So, what do I need to do here? To get rid of this divided by 40, I need to multiply by 40. And the better way to do this is to use brackets and to just write 40 outside. This means 40 times C over 40. And because I have that there, I also need to multiply on this side, so I'm going to put it in like this. Remember, this means 120 times 40. Now, let's do the math. These cancel out, and we're left with C. And 120 times 40 equals 4,800. How did I do that? 12 times 4 is 48, and put the 2 zeros on the end. Now we can check our answer by going 480. We take our original equation, which was C over 40. So C is 4,800 over 40 equals 120, and we can do some math. And we end up, yes, that is actually 120, because 4,800 divided by 40 is 120, and it is verified. Don't forget your boxes around your answers. Now, we're going to do some equations here that have some addition and subtraction mixed in with this. Actually, first, I'll do one more example more like this one. What about, nice and easy here, 5, no, not 5, F. I said a word that started with F. Strange. My brain is messed up today, I guess. It's okay. I'm back with it. F over 2 equals 1. So how do you get rid of the divided by 2, the over 2? Well, we multiply it by 2. And if we're multiplying that side by 2, we multiply this side by 2. So this becomes just F, because the 2's cancel. And we end up with 2. F equals 2. And if we check our answer, F is 2 over 2 equals 1. Does 2 over 2 equal 1? Yeah. 1 equals 1. That was strange. I see the letter F and I think the number 5. It's been that way since I was a kid. I don't know. Here we go. Let's go with P over negative 3 plus 9 equals negative 6. Let's see what happens here. Now, just remember, in these equations, to solve them, we need to get rid of the constant first. So first things first is we need to subtract 9 from both sides. Okay? And we're going to be left with P over negative 3. These cancel out and become 0. If you add 0 to something, it's still 0. And then we have negative 6, subtract 9. They're both negative, so it's still negative. And 6 and 9 make 15. So then, our next step is to get rid of our divided by negative 3 that's with our variable. And to get rid of that, we need to multiply by negative 3. Not just 3, but negative 3 to cancel out with negative 3. And this side, we're going to also multiply by negative 3. Why? Because if you do something to one side, you need to do it to the other side of an equation, or else it's no longer equal. And so you're left with P and negative 15 times negative 3. Well, they're both negative, so it's positive, and 15 times 3 is 45. So we're left with P equals 45. Let's verify this. 45 over negative 3 plus 9 equals negative 6. This is where we use BEDMAS. we need to divide first. 45 over negative 3 is negative 15. Then we have our plus 9 equals negative 6. Next line, notice I'm keeping my equal signs all lined up. Negative 15, positive 9. 15 is a greater absolute value than 9, so it's the sign that we keep. It's going to be negative, and 15 and 9 are different by 6. It's 6. Negative 6 equals negative 6. It is verified. Check mark. Let's follow the same procedure here. Okay, we have our variable here, j, with a divide by 12. But now I've kind of flipped these, right? Usually we're used to our variable coming first, but in this case, our variable is actually second. Well, doesn't matter. Still, this thing that is with it is what we want to get rid of. So we're going to add 17 to cancel out that, and we're going to do it to both sides. We're going to add 17 over here. So that means we're left with j over 12, and it's positive j, so we're just going to leave it as j. If there's a negative sign here, it would have to be negative j. But we won't worry about that right now because it's positive. And then you have negative 13 plus 17, which is the same thing as 17 subtract 13, which is 4. And then you need to get rid of this divided by 12 by multiplying by 12. We're going to multiply by 12. And so that means that we're left with j is 4 times 12, which is 48. J is 48. Let's check this by verifying. Negative 17 equals 48, plus 48 over 12 equals negative 13. Follow BEDMAS. 48 divided by 12 is 4. Fill in the rest of this that was here. And we're going to be left with 17 plus 4. It's going to be negative 13 equals negative 13. I did this correct. Let's finish this with a word problem. All right, this word problem. It says 1/4 of the team's soccer balls were brought to the game by the coach. Tina popped 2 balls with her powerful shot. Hashtag beast mode. So the coach threw out the balls. Those two soccer balls. The coach only brought 4 balls home after the game. How many balls did the team have before the game? So let's try to piece this together. It says 1/4 of the team's soccer balls. So let's maybe use S as our variable. Soccer balls, S. 1/4 of them. Remember, 1/4 means divide by 4. So 1/4 of those soccer balls, right there, is S over 4. I want to make a little note on the side. If you think about it, 1/4 of something, of soccer balls, is 1/4 times S, which is the same thing as 1 times S, right? 1 times S, which would be S over 4. So that's why I'm going with 1/4 of the soccer balls is S over 4. So 1/4 times S is the same thing as S times 1 divided by 4, which is S over 4. So 1/4 were there, and then 2 were popped and thrown away. So that means we're losing 2 of the soccer balls. And what was left over? 4 of them. So that's our equation right there. So let's solve this. We need to add 2 to both sides. We're going to have S over 4 equals 4 plus 2 is 6. And then we need to multiply both sides by 4. To get S equals 6 times 4 is 24. So 24 was the original amount that the team had. The team had 24 balls before the game. How many do they have now? Maybe the question is, how many do they have now? Well, 2 of them popped, so it's going to be 24 subtract 2. But anyways, let's verify this. 24 over 4 subtract 2 equals 4. 24 divided by 4 is 6. Subtract 2 is 4. 6 subtract 2 is 4. So 4 equals 4. It's verified. All right, that is the lesson. Have a great time. Hashtag beast mode.